Some of the most complicated chain rule examples come when we have chain rules inside of other chain rules. That is where we have to use multiple chain rules kind of in a sequence. Now I want you to see one of these, and I'll give you one or two on your WebAssign, but I will tell you in advance that unless it's an extra credit problem or something, this is not something I test over. But it is something that you should see. It really is part of what we do in Calculus 1. So let's start with this function f of x is equal to sine squared of 3x. And let's rewrite it first as sine of 3x squared. And we can see that we have sine of 3x as kind of an inside function, and the squaring is kind of an outside function. So I could think of this as something being squared, and it's that sine function that's being squared. But you'll notice that we're taking the sine of 3x. 3x is kind of like an inside function to the sine part. So we end up with a couple of things going on here. We've got 3x as an inside function to the sine, and this whole sine of 3x is kind of an inside function to this thing that's being squared. So we're going to need two chain rules. Now, we're not going to be able to use u for both chain rules because that could be confusing. So we'll use u for one of the chain rules, and we'll use, let's say, v for the other chain rule. So we'll start from here, the sine of 3x squared. And we will start by letting u be equal to sine of 3x. Then what we have is the derivative with respect to u of u squared. Right, sine of 3x is what we're squaring, so u squared, times the derivative with respect to x of the sine of 3x. And now we can recognize that 3x is also an internal function, internal to the sine at this point. So we can say, let's let v be equal to 3x. Then we have the derivative with respect to v of the sine of v times the derivative with respect to x of 3x. But we also still had back over here the derivative with respect to u of u squared that comes from the original chain rule. So we have a derivative with respect to u, a derivative with respect to v, and a derivative with respect to x. Now v and u are both functions of x, so we'll eventually get everything back in terms of x. And again, this is kind of a convoluted process, but we can do it if we're just careful about it and keep track of everything. So derivative of u squared with respect to u is 2u. Derivative of the sine of v with respect to v is the cosine of v. And the derivative of 3x with respect to x is 3. So this looks like 6 times u times the cosine of v. Or 6 times sine of 3x times cosine of 3x. Notice the angle didn't change. Once again, the angle's 3x all the way through. But this works. This gives us a nice little derivative, and it involved a couple of chain rules. But again, if we're careful about our variables, my use of color helps here potentially as well, we can work it through and get to a good final answer.